Welcome to Get Your FRQ On. This question is from 2018. It's question 2, and it is calculator active. In the question stem, we have a particle moving along the x-axis with a given velocity function v of t, and this function applies for values of t between 0 and 3.5. And we're also given that the particle is at position x equals -5 at time t equals 0. In part A of the question, we are asked to find the acceleration of the particle at time t equals 3. Since we are given that v of t is the velocity of the particle, the acceleration of the particle at t equals 3 is just going to be v prime of t. Since this is a calculator active question, we'll use our calculator. A of 3 equals v prime of 3, which is -2.118. So we can conclude that the acceleration of the particle at t equals 3 is -2.118. In part B of this question, we are asked to find the position of the particle at time t equals 3. The position of the particle at t equals 3 is given by the following definite integral. X of 3 is x of 0 plus the integral from 0 to 3 of v of t dt, which is -5 plus the integral from 0 to 3 of v of t dt. Since this is a calculator active question, we'll use our calculator to evaluate the integral. X of 3 equals x of 0 plus the integral from 0 to 3 of t dt, which is -5, plus the integral from 0 to 3 of v of t dt, which is -1.760. In part C of this question, we are asked to evaluate the integral from 0 to 3.5 of v of t dt and the integral from 0 to 3.5 of the absolute value of v of t dt, and to explain their meaning in the context of the problem. The integral from 0 to 3.5 of v of t dt is 2.844, and this represents the displacement of the particle over the first 3.5 seconds. The integral from 0 to 3.5 of the absolute value of v of t dt is 3.737, and this represents the total distance traveled by the particle over the first 3.5 seconds. In part D of the question, we have a second particle whose position is given by x sub 2 of t equals t squared minus t on the interval from 0 to 3.5 seconds. We are asked to determine when the particles are moving with the same velocity. Since the velocity of the second particle is given by the derivative of its position function, the fact that x sub 2 of t equals t squared minus t implies that the derivative x prime sub 2 of t is 2t minus 1. The particles will move with the same velocity when v of t for the first particle is equal to 2t minus 1. This is a calculator active question, so we'll use our calculator to solve the equation. V of t equals 2t minus 1 implies that t is equal to 1.571. We conclude from this that the particles will move with the same velocity at t equals 1.571. If you want more AP Calculus AB free response question solutions, don't forget to like my videos and subscribe to my channel. And you can even follow me on X at x.com/getyourfrqon.